Yeah, see you, and see you in the next question. Students, let's look at this question here, which is on the topic of discriminant. Let's see how we can do this proficiently. So the equation of the curve is y equals to negative 2x squared plus kx minus 4x plus k, where k is a constant. Show that for all value of k, the curve has two real and distinct roots. Okay, great. So let me just try and visualize this using Desmos calculator. So in this graph here, what I did was I just plotted this equation with k, the variable k. So as you could see that as I vary my k, this curve has always will always cut the x-axis twice. Okay, no matter what value of k I put. So even if it's a huge, you see that the graph here actually sways left to right. All right. So what I'll suggest is have a play around with this graph. So I'll put this link in the description so you can have a feel of how this works. Or you could just go to desmos.com to actually plot this graph out. Okay. So now, how do we show that this curve here always cuts the x-axis? So that's the reason why we use discriminant. Now, one of the reasons why we use discriminant is because we know that x is equal to minus b plus minus b squared minus 4ac over 2a. And the discriminant comes about because of this function, this expression here. You can't root a negative expression. So, and this equation here, as long as this is positive, we know that this will we have two solutions because of this. Okay, so that's the reason why discriminant is very useful. You don't really need to assess the whole thing, but just by looking at the discriminant there. So here, what I need to show is that for all value of k, so what we're going to do is discriminant. Okay, d will just be b. Oh, great. So I need to rearrange my b. This case here, k minus 4x. So b squared minus 4ac. There you go. Okay. Now I need to show that this is always positive. So now k is a variable, right? So this case, I'm going to k squared minus 8k plus 16. This is plus 8k here. Then after which we have k squared plus 16. There you go. Now, this is obviously always positive because since k squared is always bigger than 0, right? Because no matter what k value that I put in, k would always be a positive, or at least a 0. Okay, so hence d, which is k squared plus 16, will be bigger than 0, or rather will be bigger than 16. Okay, it will definitely be bigger than 16 or bigger than 0. Cool. So hence the curve has two hence curve has two real and distinct roots. Okay, for all okay, that's it. So that's how I show it. Let's look at the subsequent one. So as for the subsequent part B, you're told to find the range of values of k for which y equals to 3k minus 4x does not meet the curve. Okay, great. Let's see how we can do this. So I'm going to plot this same thing into the graph, and we'll just try and assess what is going on here. So this is 3k minus 4x. Okay, this is actually a straight line curve. You should know that it's a negative sloping and it cuts. This is the y-intercept here. So by plotting in there you go. This is the graph that we're looking at. With a different value of k. Well, that is pretty cool. As you can see, it sways. Okay, this intercept here would be my 3k. So 3k will be my intercept, and after which it just looks okay. So this is how it looks like. Okay, when you vary the value of k, it just cuts here and it doesn't cut. So the question now is, what should the value of k be such that it does not meet the curve? So in other words, we do not want y1 and y2 intersect. So just sub y1 into the equation, okay, which is y equals to, maybe just start with the 1 here, easier. So this will be my y 3k minus 4x equals to minus 2x squared plus k minus 4x plus k. Okay, so this part here, once done, what we need to do is actually just move everything over. So this will be, I just want this to be positive, it's easier. So this is plus 3k. So maybe I just do this properly. Plus 3k minus k minus 4x minus k equals 0. After which 2x squared plus 3k minus 4x minus kx plus 4x minus k equals 0. And this would cancel away each other very nicely here and here. And my k over here, this will be 2x squared plus 3 minus k, 3, sorry, the minus k plus 2k equals 0. Okay, so that's how. So find the range of value of k which does not meet. Oh, this is a pretty interesting one. So how do we go about doing this? 3k, 2k. You need to solve this expression here, but there are a few ways of solving this. Either you factorize it, or you use oh sorry, this is 0. Okay, can. Oh, does not meet the curve. Does not meet the curve just means that you do not want this to, this doesn't have real solution. So this do not have real solutions. Okay, because it doesn't meet. So this case here, what we're going to do is actually just put, if it doesn't have discriminant to be less than 0. So minus k squared minus 4ac less than 0. Okay, so this will be k squared minus 816k less than 0, k minus 16 less than 0, and after which we have got we need it to be less than 0 here. So draw it out. This will be a quadratic inequalities here, 0 and 16, and you need this to be here. Okay, so in other words, this will be k will be 0 and 216. So let's look at our graph there, whether it makes sense. So from 0 to 16, maybe I should just extend this out. This should be to negative 20 to 20. Okay, so it should be from 0, which is where it just nice cuts, right? 16, there you go, it will chase out. 16, there you go, it just cuts again. It's interesting. So there you go, this range here which it doesn't cut. Oh, that's pretty cool. So what you do is please make use of the graph. I'll put it alongside with the worksheet. Then just play along with this graph to understand this question proficiently. Okay, so any question, please let me know, and I'll see you in the next question. So let's look at this question here, which is on discriminant. So you're told to show that for all real value of m, this equation has no real roots. Okay, let's see how we can understand this proficiently. So what we do is essentially when m varies, you need to show that this curve, this is a smiley face curve, right? Because you need to show that it's always above the x-axis. So by using a Desmos curve, similarly, I'm just going to put like m here, and this is minus the value of m as it varies. As you can see that it sway from left to right, right? But it never ever touch or cross. It never cross over the x-axis here and render a solution, right? So the question now is, how do you show that it's always above the x-axis? So you use discriminant. In other words, you need to show that the discriminant is always negative, right? It doesn't have a real solution. So x squared plus 2mx plus 2m squared plus 1 equals to 0. So this case is pretty okay. What you need to show is discriminant. Discriminant. Okay, and you need to show that this is b squared minus 4ac. There you go. So this is b squared minus 4ac. So this is 4m squared minus 8m squared minus 4. Alright, so this is a discriminant here. And once this is done, is 4m squared minus 4. This is pretty interesting. Because this show that this is always negative. So I'm going to put 4m. I'm going to factorize this out. This m squared plus 1 is obviously always positive, right? So we could write this as, actually this is, you could already see that this is always positive. So you can show that, but I like to factorize -4, but okay, doesn't matter. I think what we likely show, m is actually bigger than 0, m square, bigger equals to 0. So in other words, if f4m square would just be less than 0, right? If you multiply both sides by negative. Okay, so this is obviously a negative, because this is always positive. So when you take a negative number, multiply with a positive number, it'll be a negative number. And after which you just minus 4. So 4m square minus 4 will just obviously be less or than equals to -4. So in other words, hence discriminant d would just be is less than 0. Okay. In other words, hence x plus 2m squared plus 1 equals to 0 has no real roots. That's how you show this question here. Okay, so that's how you do this question proficiently. Any question at all, please let us know, and I'll see you in the next question.